Hello, we are Team 27 and welcome to our video demonstration for the RBE3001 Final Project. For this project, we were tasked with programming a 4 degrees of freedom robotic arm that would autonomously detect 3D printer balls, pick them up, and sort them based on their color. To accomplish this, we utilize a combination of forward kinematics, inverse kinematics, velocity kinematics, and real-time image processing. This project took a term to complete as we slowly added new functionalities to the robot each week during the lab sessions. Let me walk you through how we did it. Using MATLAB's built-in color thresholding feature, we were able to identify the balls based on their HSV values, allowing us to determine the color for each ball. We chose HSV as our preferred method over the other options because it effectively separates image intensity from color information. After successfully detecting the balls, we applied a series of morphological operations to complete any missing sections of the circular shapes and refine their edges. This enabled us to utilize the centroid function, which provided us with the precise x and y coordinates of the center of each ball. We also added a polygon mask so that the robot would only pick up the balls that were within the checkerboard field, and a condition that it would only pick up if the radius is bigger than 10 millimeters to filter out smaller objects. Our sorting algorithm picks up red, orange, yellow, and then green balls in the exact same order. It repeats this until there's nothing left on the field. If there's more than one red ball, for example, it won't pick it up until it looks back again. Once we knew where the balls were, we had to tell the robot to get there somehow. To do this, we developed an inverse kinematics method for the robot, which would take in an x, y, z, and alpha, and spit out the corresponding joint angles used to achieve this position. The inverse kinematics was by far one of the most challenging parts of the project. This is because mathematically, inverse kinematics problems can have multiple solutions, but in our case, only one of the solutions was right. To combat this, we developed a series of if statements which check using our forward kinematics which of the solutions is acceptable within a certain range. As part of our bonus points, we made it so the robot could live follow a ball along the field, as well as pick up other similar color objects. But yeah, that was our final project. We had a great time coding with the robot, and we learned a lot as well. Thank you so much to Prof. Gabriel and the entire RBE staff for helping us throughout the project.